Hello everyone, so this time I will try to explain the solution to this problem. I've already solved it and I had a really tough time solving this problem. So the statement goes like this: you are given a string of length n and a dictionary containing keywords. In how many ways can you create the string using these words? And everything consists of lowercase letters A to Z, and we have to take modulo for the final answer. So what does the question mean is that look at this sample test case. So we have to create this word using these words. This is our dictionary, and we are allowed to reuse the same word again. And for example, there is AB, so I can use AB and then AB again and then C to form the word. And now there is ABAB, so I can use ABAB once and then C. So that way I can create the string two times. So after reading this problem, I took the dynamic programming approach, but that approach like gave me TLE. So and that's where I started to struggle. So basically I first heard of the recursive solution, which gave me TLE, and it was not that surprising. Then I memoized it, and that also gave me TLE. So finally I coded up the tabulation solution, and when I wrote the tabulation solution, I was like, okay, I am done with this formula. This will certainly be accepted. But to my surprise, even this wasn't accepted. So then it got me wondering, like, what can I do to make this solution accepted? So then I found the trie solution, and actually when I read this problem I thought trie will be used for this problem, but I didn't really get the idea of how can I use a trie for this problem. So yeah, that's it. So first let's take a look at how the DP solution works. So first what are we gonna do? Let me write the test case here. So it was AB, and then C, and then 4. First word was AB, and then AB, B, and then C, and then C, B. Okay, so what we do in this DP solution, first of all, you need to understand what does DP of I represents. Okay, so DP of I represents what are the number of ways of creating the string from the given index. So for example, I is at here, I is at this place. So what are the number of ways we can create this part of the string? That's what I represents. So I is representing the number of ways of creating the string starting from I to the end of the string. Okay, so and that's how we got the solution. Like when I is here, we get the number of ways of creating the whole string based on the given dictionary. Okay, so that's what the DP of I represents. And now hmm, so how do we approach this problem? Like, let's just discuss about the tabulation solution. So the base case, what's the base case? So like when I is here, we have an empty string. When I is equal to the size of string, we have an empty string. So we considered it as like it is complete and there is only one way of creating it. So the size of a DP array is n. Okay, n is the size of the given string. So size of a DP array is n, right? And what we do, we set DP of n as equal to 1. This is our base case. Okay, the base case. This is our base case. And so, wait a second. Forget it. Yeah, so this is a base case, and then what we are gonna do, we will start. Okay, so we start from n minus 1 and we go till 0. Okay, and what we do, we check. Okay, if we check our list of words, so we do auto ampersand word our list of words. So we go through our list of words, right? And while going through a list of words, we check if the word matches our string starting from I. Okay, s of I, like dot 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 to end, whatever the end of our string is. Wait a second. Okay, and then end. So so s of I dot 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 to the end is not to the end, actually to I plus w dot size. Okay, so the size of the current word, and we do check if the size of the word is less than the end of the substring. So if it matches with w, so we have found that match. And one thing to note is that, let's say we have abc and the substring is ab, and let's say we are here, so we have matched only this part. I is at here, okay, and we have matched only this part, so this part is still remaining. So what we do, we want to find out how many ways there are of creating this part based on the dictionary. So what we do, dp of I plus equal to dp of I is here, and we want to find out number of ways of creating this part. dp of I plus w size, and that's, oh sorry for my handwriting, my drawing work. So we calculate this, and that's what we have done in the code. dp of I is equal to dp of I plus w size. So we are finding the number of ways of creating the remaining part. Okay, so you can see the problem here is that this loop this loop, like every going through the whole list, whole dictionary each time to check whether there is a like substring that matches some part of our current string. So we are checking it again and again and again, so this really increases the complexity. And this is where the trie data structure comes in. So what we do in a trie data structure for, and I'm expecting like you all know what a trie data structure is. So what we do in trie, we have a dictionary, okay? Like let's call it words. We have a list of words, right? So what we do, we insert all of these words into a trie data structure, and so we insert them into a trie data structure, and what we do, we mark the end of words. So let's say I am creating a stop. So and stop, basically I take the node, trie node, and if it is a ending node, I mark it as true. Okay, and how we are creating the trie, that I like normally what I always do is like use a map and create a trie node, like a trie node, right, and use pointers. This is how I do it usually. But today I saw a implementation of trie and I was really impressed by it. Never seen something like that before. So how it works is that, so you create an array, 2D array. Okay, so let's say int, and then let's call it t. The size is, the number of rows can vary, so let the rows can be x, and then this will be 26. Okay, because we are having lowercase letters. And then what happens is whenever a node is added, and we also make use of a counter variable, so let's call it count. Okay, okay, let's just call it C right now. So we make use of a counter variable, okay, and anytime we find a node, okay, I think it's better to explain it in the code. So basically initially we are at 0th node, right, and we check if there is a, like if the node is uh, pointing to any other node. So initially every node will point to 0. Okay, so this is the 0th array, and assume we have 26 segments here. Okay, and the A will be at the 0th index, and currently all of them are pointing to 0, right? All of them are pointing to 0. So what happens whenever it's pointing to 0, we, so this part is variable, so we add another row of 26. Okay, and same thing, empty segments, so we add another row. And what we check is, let's say my current character of the string was, let's say it was A. So I checked A was at 0, which meant it was pointing at nothing. 0 means it's pointing at nothing. So what I will do, and initially my counter is set to 0. What I will do, I will increment my counter first, okay, and then my the character A, it will point to, it will no longer point to 0, it will point to 1, and so this will be linked to this. Okay, and now let's say my string is AB. Now here B, currently B will, when the array is initially created, it will point to 0, but now I have B, I will check if B is pointing at something. So B is pointing at nothing, so here I will, it will point to 2, and another array will be added to the trie, and B will like point here. Okay, this is how it keeps on creating. And now let's say AB is done. So in my stop array here, when the loop ends, so AB, I have only have two letters in the string. Okay, we travel through the size of the string. So we stop once the size is reached. So wherever the node stops, we mark it as true. And do note that after the end, like once we have added the node, we like update our node variable. So like when I set is node to 1, so then I mark node as 1. Okay. Similarly, when I updated it for B, then node would have become 2. So this is how the trie structure is created. And you see, we don't need to like keep manipulating pointers and stuff. Now let's say another character is added. Now CB. Okay, we are inserting another node into trie, another string, and node initially is 0. So now C comes. Let's assume C is over here. Okay, third. So initially C is 0, which means it's pointing at nothing. So now the value of counter was 2. So counter will be incrementing again, and this will become 3. Now another node will be added below here. So, and whatever node will be added, C will point to here, and similarly will check for it, B in it, right? And that's how this works. So basically one array keeps adding beneath whenever we encounter a new sequence. So this is the logic that I used. So what you will find in the solutions online, basically these are the constraints. So what they do, they all before they reserve the space beforehand. So I will show you it here. Analysis. So you can see he defined the sizes based on the constraints and he reserved the space beforehand. But I didn't do that because, like, of course, in competitive programming, people do things like these to save the time. But when we do real world coding, we won't be reserving any size beforehand, right? So that's why I implemented a way using vectors where basically I am like not allocating space beforehand and adding nodes when we need it, because you see one advantage of like allocating whole space beforehand was he doesn't need to like, if the node is not pointing to anything right now, you just need to update the counter and upgrade the node's reference. Okay, the node, what the node is referencing to. But now since we haven't reserved any space, we need to do these two additional things. Okay, yes. So basically add another row to our trie and then increment the trie node count and point the current letter to the node, to the node's index. And that's how this works. Okay, and how are we saving our time here? So we discussed about like DP, right? We have to count DP plus the W size. So how we are reducing the time that is taken? So instead, you remember we had to traverse the whole list here, whole list of words. But the advantage of trie is that what we are gonna do, like before, we will travel from n minus 1 to 0, and now for I, for ith index, we'll check and try, like we will traverse the I traverse from uh, wait a second, we have a trie data structure. Okay, trie. So we will traverse our trie from ith letter. So our string is s of I. So we, for example, AVAC. So let's say my I is here. Okay, this is where I is. So I want to know how many ways there are of creating this string BC. Okay, and in our trie data structure, you remember we inserted all of the words here. So if there is a way of creating BC, this part should be pointing to something. So what we do, we for s of I, like for ith index, we start traversing our string and we check our trie data structure. And if we any point we encounter a stop in our trie data structure, because stop means we have reached the end of a word. For example, there is B and C. Let's say our trie has, there was a word in our dictionary that was B. So B will match. So stop of whatever index B was pointing to will be true, right? True. So I'm denoting true with 1. So it will be true, right? So therefore we will add the number of ways of creating being would be represented by dp of index of b. Okay, whatever index of b is. Okay, and we will add this to our dp of I. We will add these. Struggling to draw. Okay, and that's what we have done. So count number of ways. Okay, and we are passing our current index we are on and our string, and we basically traverse from here to the end, and we are counting the number of ways. Like if the node is not present, we will simply return the number of ways we have encountered. Else we will check if the current node is a stop node, and if it is, we will add the number of ways. Okay, because dp of I represents the number of ways of creating that string, right? Remember? Hmm. So yeah, this is how we solve this problem, and you can see it was, I made so many incorrect summations. Yes. And as you can see, this was accepted, thankfully. Hmm. Okay, you might be wondering why we are doing I plus 1, because we are doing I plus 1 because the current node is a stop node. Okay, so the current node is a stop node. So basically we have found match for B. Okay, I made a mistake here. This would have IDX plus 1. We have found a match for B, right? So we want to know what are the ways of creating this part, right? That's why we do dp of IDX plus 1. Okay, this was small error that I made here. Hmm. I know my explanations are probably not that good, and that's why I'm making these videos actually, so that I can get better at explaining stuff to other people. And also, like, actually there are better things for me to do, I guess. But yeah, I don't know in which direction to move, and nor do I want to just sit still. So yeah, I'm making these videos. But hopefully I get better at explaining. Also, I think it is important for me to learn explaining stuff, because like if I get a job and like in interviews and stuff, they do ask you to explain stuff, right? Like explaining your approach to the interviewer. Yeah, that's why I'm making these videos, so that I get better at explaining my approach. Hmm. And that's it, guys. We have to like strive, keep striving to get better. Okay, so that's enough, I guess. Okay, bye.